Science for Wednesday. I'm on page 464. We're talking about measure current, voltage, and resistance. You guys should have handed in a map of a circuit to me yesterday. You can take a picture of a drawing that you did. Remember, you can look it up online. Okay, so here we go. 464. Measuring quantities like current, voltage, and resistance in an electric circuit makes it easy to understand what is happening in a circuit. This is especially helpful when troubleshooting electrical problems, such as why an electrical dryer doesn't produce any heat. Meters are devices used to measure electrical quantities. An ammeter measures the current. A voltmeter measures the voltage across 2 points of a circuit. Ohmmeter measures the resistance, and multimeter combines these three functions in a single meter. These meters are connected in different ways. The diagram below shows a voltmeter and an ammeter are connected in circuits. So here's a voltmeter and an ammeter. Just hold on. Hey, David, do you have your meter downstairs that measures voltage? Ooh, David's gonna bring it. Okay, to determine how much current is flowing, an ammeter is connected to a series to test the power source and the load. What kind is this?
Well, that can do, it's a multimeter, so it can do
multimeter.
DC and AC voltage. It can do resistance, capacitance. It can check for continuity. Continuity is whether things are connected to each other or not.
So one is positive and one's negative?
Yes. Yep. And if you look at the bottom, if you're going to read anything but current, you use this terminal. And if you're going to read current through the meter, you use that terminal, or if it's a really high current, you use that terminal, and that'll tell you the current flowing. Yeah.
They're learning about circuits and and reading resistance.
Well, if you want, we could set up a live demo because I have hardware over here.
Ooh. Yeah, we could do that next week. I mean, we can record it this week and do it next week. Okay, Davin's.
You can keep that for now.
Davin said I can keep this for now. So technical. Okay, so here we go. To determine how much current is flowing, an ammeter is connected to a series of tests to test the power source and load. To measure voltage, the voltmeter is connected to a connected and parallel device being tested. The circuit does not actually need to be broken to measure the voltage. The measurement probes can be touched to parts of the circuit that need to be measured. So that's where you would touch the metal things onto the different parts to see how much voltage is going through. To test a load, one component in the circuit is removed and tested separately. Breaking the circuit. Several types of switches are used to control the energy flow through a circuit. Now, can you think of a switch that we use on a regular basis? Like a light switch that would break or open the flow of voltage, right? You know, the switch is open and close a circuit, or to change the path of electricity in a parallel circuit. Remember, the parallel ones are the ones that like go like this, so like if you shut off this light keeps going. Okay, switches are generally used to turn on various devices on and off. What might be another reason to have a switch on a circuit? Maybe to save electricity or for safety reasons. Okay, it is important to use care when handling electrical units and respect the dangers they present. What electrical safety rules do you know? Okay, don't shove things in sockets. Don't play with electricity. You're gonna get hurt. Can you think of safety precautions that you or your parents take when working around electrical equipment? So if we're gonna work on a room, I know David will go right over here and shut off the electricity for the whole room so we don't get shocked if we're taking on and off plates. Okay, most of the circuits in the home or business are connected in parallel. This means that unplugging or using a switch to turn on and off one device will not affect the other devices in the circuit. How would you turn off all the items in the circuit without disconnecting one individually? Switch it off for the whole room, right? Every device we plug into a circuit gets the same voltage no matter how many there are. This allows them to work properly. Recall that each load we add to the parallel circuit increases the current and lowers the resistance. This makes it easy to overload the circuit. Overloading a circuit can cause overheat and causes fire. What devices in your home have helped to prevent those problems? So if you've ever looked at, I know right away, my hair dryer, it has like a reset and a set button on it. So even though I plug it in, I have to push the reset button and then it will work. If it gets too hot or too much electricity is being used out of that one outlet, it will pop off, and it's like a safety thing. What can you do to avoid this situation in your home? Don't plug in too many things at the same time. Okay, moving on to page 466. I got a timer going here. Okay. A short circuit problem occurs when isolation wears away from electrical wiring. So if you get like a crack in your wiring or it breaks somehow, that's dangerous, because then unprotected wiring provides a low resistance path for current flow. The current may jump to another material and cause sparks. When the exposed wires become hot enough to start a fire or cause shock. What can you do to prevent this from happening in your home? What do you think? Do you think you should replace all wires that are broken or cracked? Probably. When people can be severely injured by touching exposed wires in electrical circuits. Our bodies have high resistance. Electrical current that passes through our bodies will slow down and release thermal energy. Thermal energy is heat, right? The electrical energy can cause burns or cause muscles to jerk violently, which is harmful to the heart. If someone is receiving an electrical shock, you should not touch that person until the power source is turned off. Why do you think so? Because that electricity that's going through them, if you touch them, it will start going through you also. The list below describes some ways to prevent electrical shocks and burns. How will you share this information with the ones you love? Never touch electrical outlets with your fingers. Never play with electrical cords. If you are in the bathtub or shower, don't touch anything electrical. When you're playing outside, never play around electrical wires. Stay away from marked areas that say danger, high voltage. Never climb utility poles, transmission towers, or fences around that substations. Do not climb trees near power lines. Never throw objects at wires or utility poles. Only fly kites during dry weather and open spaces away from power lines. Pretty self-explanatory. I feel like that's like, I'm going back to get my sticky note because we have 2 vocab words on this page. It's pretty common sense. If it says electrical, don't play by it. Okay. A fuse is a device that limits the amount of electrical current flowing through a circuit. So we have a fuse. Who has a fuse box in their house? All of you. All of you do. If you have electricity in your house, you have a fuse box. That's the safety shut off for your house and how you get power. Okay, so a fuse is a device. I'm finishing this page just so you know. That limits the amount of electricity electrical current flowing through a circuit. A fuse is connected so that the current runs through it. If too much current moves through a fuse, a piece of metal melts or the circuit breaker switch is flipped. This breaks the current or breaks the circuit and shuts down the flow of electrical power. Fuses have to be placed after they have blown. Some fuses have to be replaced. Okay. Older buildings continue to use fuses and fuse boxes that limit the current flowing through the home wire. But many modern buildings use circuit breakers. That's what we have in our house. So a circuit breaker is the next word. Circuit breaker. You smell bad, cat. Smelly cat, smelly cat. Okay. Are special switches designed to open when too much current passes through them. So these are switches that open when too much current. It's like a safety shutoff. Why is it important to check safety equipment regularly? Well, if one of those circuits breaks and it doesn't automatically shut off, you might have a fire, right? The advantage of circuit breakers can be that they can be reset instead of needing to be replaced. It is important to correct the problem of electrical hazards that set off circuit breakers first before resetting it. Why do you think this is important? Well, if it already blew the circuit once and you plug it back in and reset the circuit, guess what? It's gonna blow it again because it's just too much power right there. Okay, so today you guys are gonna do page 467, 1 through 4 on the concept check. So page 467, 1 through 4 on the concept check. See you tomorrow.